Okay, we're going to look at number 12 here. Our goal is to find the domain and range and use appropriate notation to communicate that. First, we're going to take a look. This is a square root function. So square root functions are a little bit unique in that they have kind of a sharp edge or a starting point where they don't go any further in that direction. So what I've got here on this side is the screenshots and the syntax for getting these into the TI-84 calculator. One thing I'll notice here in my screenshot is the cursor was blinking when I took this screenshot. So there's a negative in front of that 3, there's a negative in front of this 8 here, and the cursor blocked that out. Okay, so if you put that in and you use the window here that we have on paper just to kind of match that in scale, you'll notice the graph pops up, and that's what we see down here. Now you have to hit trace in order to be able to locate points, and trace may or may not pop up right on the end of this graph. So the way we find the end, kind of the hard stop on this curve, which is x equals 4, and the output value there being y equals 3, is you go to the inside layer of the radical. Okay, and you take that amount, I'm just going to write it over here, and you're looking for the 0 of that. The 0 of this is very easy to solve for. We just add 4 to both sides, and that's how we get this x value where the curve down here starts. Okay. Now, the reason that's important is because if we look at x equals 4 and go any lower than 4 in the radical, we'll end up with a negative result in this square root, which is going to be undefined in the real numbers. That's why on the graph here, we don't see the curve extending any further to the left than 4. So let's go with that in mind, and I'm going to change to blue here to talk about domain. Everything in terms of inputs happens from 4 and greater than, or to the right of 4 on the number line. So you could kind of put an arrow on the end of this curve and say, okay, the domain has to go from a minimum value of 4, and we get to include that with square brackets, all the way up to infinity. And another way to say that, you could rewrite that as x can be anything greater than or equal to the real number 4. Okay, so that's the domain. And just to highlight one more time, you can't plug in, say, negative 4 and get anything on the graph. The only values you can plug in are 4 and bigger, and we see that very clear here on the graph screen. Now, the idea for range, switch to purple here, has to do with the height. So you can see at this end point that we used 4 to get to, it has an output value of 3. So this is interesting because the highest, think of the outputs as heights of the function. The highest it'll ever get at this point here is a height of 3. Okay, so think of the y-axis. I know that it's on the graph, it's a vertical axis, but think of it as a horizontal number line like you've possibly seen back in middle school in Algebra 1. And just kind of notate where 3 is on the number line. It's somewhere between negative infinity on the extreme left and positive infinity on the extreme right. And the reason I do this is when you go to write interval notation, it's really helpful to think of it as a number line issue. So the highest the graph will ever get is 3. Every other height is going to be below that 3 value. As this curve keeps going down and down and down to the right, you're going to get all these other possible heights, which are approaching negative infinity. So I would kind of graph this on a number line as everything below 3, solid dot on 3 because it includes it. And the way that transfers to interval notation is we always start on the left with a number line with our lowest number, and that's the same with interval notation. Lower bound or lowest value on the left, highest number on the right. The parentheses just communicate whether those values are included in the set or not. So 3 is a real height. That's why we have the square brackets around it. And negative infinity is not so much a number as it is a direction. So we cannot contain or get to negative infinity. We just point to it with a round bracket. So that's the interval notation. And the inequality notation, which is just as good, could be written as y less than or equal to 3. That is the gist of number 12 on A2. I hope that helps.